Hello dear students, welcome to lecture 6 of Artificial Intelligence and Machine Learning course. So today I am going to show you a practical example of Perceptron algorithm. To do that, I will compose a console.NET Core application and I will use a Core framework to do that, to make a Perceptron classification. So let's choose our folder here. Okay, let's name our project as lecture 6 Perceptron example. Okay, so Accord framework provides a library for us to do machine learning tasks. Perceptron. Okay, so there is Perceptron learning class, and there is also neuro learning namespace. Let's read their library details. So this is supervised learning. Actually, it inherits supervised learning as expected. There is the methods, okay, constructor properties, and okay, this is the class I need. An example of Perceptron learning. Okay, there is a Wikipedia article. So it says view source, request example, backpropagation, deep neural network. Okay, there isn't any easy example so far. Okay. Okay, let's check their sample gallery. And I believe there was one example for this. Okay, classification. Okay, Perceptron. Okay, so let's download their application and then we can apply the used methods in this application. Okay, it is downloading the Perceptron. Okay, so the Perceptron example is downloaded. I'm extracting the data. I am opening their solution. By the way, our solution is also composite. And to use a CoreNet framework, we are going to install it from a NuGet as a NuGet package. Okay, you see there's Accord.net. We may need to install some more libraries as well. Okay, and this is their example. It is made within main WinForms. Okay. Okay, so there is one layer Perceptron and Perceptron. Let's check the real Perceptron, which probably have more layers. Okay, chart add data series class 1 color chart series the type dots 5. Okay, there is add data series method which is, and there is also chart. So what is chart? Okay, so this is the AccordNet control framework from Okay. Set text. I am looking for the method example where they used the perceptron training and evaluation. Okay, show training data. Okay, there is the examples. Okay, you see, this is the two-dimensional array, and they assigned the data to arrays here. Then, okay, this is show update view list. Threads, learning rate. Okay, search solution. So this is the worker thread. Okay, it says prepare learning data. For learning data, as far as I see, a coordinate uses a jagged array, which has two arrays. I have explained it and show jagged arrays on my object-oriented programming language course. If you are interested in that, you can check it. Let me show you. In our channel, we have shown it in I think, okay, lecture 5 or lecture 4. Okay, watch all of them. In one of them I have shown it, or maybe it was in introduction to programming. Yeah, introduction to programming lecture 5. You can watch this to learn more about that. Okay, and let's continue to analyze. So there is variables and there is output. Output class is used to determine the class of the input, and it is used for training and it is used for evaluation. However, when we are doing training, we are separating data, we are splitting data, and we don't show the test data to the training model. Okay. So we separate them and then we train data and then we use the test. We have explained it in the previous lectures. Okay, 1 minute. Okay, so this means that we have to provide our input data as arrays of arrays. I mean the array of arrays, and output will be also array of arrays. Okay. And you see it says samples. This is the length of the array, and here the output is set. The inputs are set, and then this is the method. Okay, so now we know how we need to provide our data. As I explained it previously, the most important, I think the hardest part of machine learning is that you have to turn your real world data into the feature set so that algorithms can process them. Okay, in Perceptron, should we scale the data? I think we should do that, and let's find our real world dataset. I will use Iris dataset, or yeah, Iris dataset is good. I had downloaded it previously, but I am going to re-download it so that you can see. Okay, so they explain the data and their name, so you need to understand them before using them. By the way, in the project that you are going to make, you need to compose feature set yourself. That is that will be my mandatory requirement. So you see, they have already normalized the data between 0 and 1. Oh, they didn't even normalize. Okay. Okay, so we can try to work with this way, and then we can normalize it to have better values. Or it may be even normalize it, but Okay, it is not. It's not very much important. So I'm going to use this data to do perceptron training on it. By the way, you can use this method on any data. Okay, as long as you can compose feature set of the data. So I'm going to say iris data. Perhaps we may even find a better data set. Let me check that if there is any. But it shouldn't be too hard because I need to show it in one lecture, as you can guess. Okay, let's return to datasets here. Oh, there were also a link here. Okay, so number of attributes and instances. Avalon, adult, what are they? Okay, let me check their data folder. There's Avalon data, and let's see it. Okay, so the features are written like this. So what is this data about? I mean, this data set is about. Okay, I think we can use this. Let's read the dataset information.
Predicting the age of abalone from physical measurements. The age of abalone is determined by cutting the shell through the cone, staining it, and counting the number of rings through a microscope, a boring and time-consuming task. Other measurements, which are easier to obtain, are used to predict the age. Further information, such as weather patterns and location, hence food availability, may be required to solve the problem. From the original data, examples with missing values were removed, the majority having the predicted value missing, and the ranges of the continuous values have been scaled for use with an AN by dividing by 200.
Okay, so the data is already scaled. Okay, and maybe we can find a non-scaled data. Okay. So this data is about predicting the task is to determine. This is two class problem. Okay, I think I will use the Avalon dataset, and I believe the last line is about their ages, but I'm not sure. Let's check the Avalon dataset more. There is names. Okay. So you see the original owners of the database is Marine Resources Division. This is a real dataset. This is not something that is made up for showing purposes. Okay, date received, past usage. Okay, there are already research on this dataset, of course. Okay, so with linear discriminative analysis, they have obtained 100% success, I believe. But I am not sure if these are success rates or error rates. I believe these are error rates. With KNN, it achieves, you see, 3.57 error rate, which is extremely good. Probably this is over 96%. And with C.5, this is decision tree algorithm. They have obtained about 79%, 80%. So this was final 1044 examples. First 3033 is used for training. And these are other classification. Oh, so these are probably the real success rates, which are extremely bad. Okay, yeah, these are real. Because with linear discriminative analysis, you can't obtain performance probably. Okay. So you see, this data set has 4177 instances. So with input, each one of the array, you see the right side of the jagged array is being features and left side is holding each instance of data. Okay. And features is, there are 8 features for this data set. Attributes, number of attributes are 8. And attribute information. So the first attribute is the sex of the I think this was a plant or something. I'm not sure. The abalone. Let's call it abalone. Let's see what is abalone. Okay, so this is abalone. Oh, these are animals. Okay, this is abalone. Okay, so the first one is the sex of the abalone. It can be either male, female, or infant. And the second parameter is the length. It is measured as the longest shell measurement. The third is the diameter. You see here right now, this is how you generate feature set of the data. Whatever the problem is that you are trying to solve, you have to compose your own feature set. And how you are going to determine your feature set is totally up to you. It has to be well selected. It has to be sufficient enough to classify, and it shouldn't be too much. It shouldn't be too much that it won't be overfitting. And okay, so length, diameter is the perpendicular to the length, height with meat in shells. You see these are continuous data. Actually all of them are continuous data. Therefore you have to you can scale it. Since these are continuous data, if you use decision trees, you have to make them categorize. However, this should work very fine for example, KNN or Perceptron algorithm. Height, whole height as a grams, whole abalone, shocked weight, weight of the meat, viscera weight, gut weight after bleeding, shell weight, and rings. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the ninth attribute is the class. So there are 8 attributes, 8 features, and 1 class. So you see these are the class, which is the age of the abalone. So our aim is that we will try to generate a model that will be able to predict age of that abalone from these input. Okay, so for example, 3117th example will not be provided to the training dataset training phase, and it will be asked to the trained model, and we will expect the output as a 10. Okay, if it is 10, then we will have a success. If it is not, we will have a failure. Okay, so I am going to use this. I have copied this and I will paste it into our projects binary folder here. Okay, Okay, so now let's first compose the input data. Okay, since this is the console application, I'm going to write a console read line, and then I am going to add using system IO. Okay, then file read lines. Okay, let's add a for each. And here, okay, from first line it is starting, and I'm going to delete the last line. Okay, and the data is separated with commas, as you can see, so it is really easy. Voila. Then I am going to compose my input. It is double. By the way, when composing the array, I have to provide the initial size. To do that, what I am going to do is, first I am going to count and actually I'm not sure if it is possible with an easier way or just with for each or something. Okay, I already know this way, but yeah, this seems like the best way. Count and data, and here. So this will be the size of the first array, which will hold all of the instances. Okay, 1 minute. Okay, so the first array holds all of the instances. So now that we are initializing our array, you can go step by step when you are programming the application the first time. It is important so you can be sure that so far your application is working as expected. Okay. Okay, I put a breakpoint. Okay, so the array is initialized. Now I am going to read the data. To do that, I'm going to do read all lines or read lines. We don't need that. Then I am going to make it like this. Oh, I need 0 counter and equal to new integer. Okay, I think I can use like this, split by comma 2. Oh, I don't even need to do that. Oh, it requires me to define a double array, so I'm going to do what I'm going to do is select convert to double and PR, and I also need to provide format provider. Oh, here. I think this is a good one. So you will also understand that. So you know there is a floating point separator and thousand separator. The floating point separator in Turkish is comma, and in English it is pointer. Okay. Therefore, you have to be very careful with that when you are working with floating point numbers. So I am going to provide my own globalization. So the number decimal separator is this one, and the group separator. Okay, so this is the decimal separator and this is the group separator. I think it is very clear, and I'm going to provide this format, and then I need to turn this into the array. How am I going to do that? Is like this. Okay, so you see now it works. What am I doing is I am selecting each value of the split by comma, then I am converting that value to double with my format provider, then I am converting all the selected values to array. Okay, so when I run the code, you will see how the input array is initialized. Oh, okay. So you see, I cannot format some of the data like categorical data, which are M, F, I, and I should treat them equally somehow in my algorithm. So okay, so how should we treat them? Okay, you see, this is exactly what I'm looking for.
An overview of categorical input handling for neural networks. A quick guide to summarize many approaches for handling categorical data, both low and high cardinality, when pre-processing data for neural network-based predictors.
Okay, this is important. Let's read this.
What is categorical data? Before diving into ways of handling categorical data and passing it to a neural network, I want to use a few words to describe what it is. In my own words, categorical data is a set of symbols that describe a certain higher-level attribute of some object, system or entity of interest. As an example, the concepts red, blue, and green describe the fact that some physical objects radiate a specific distribution of the electromagnetic spectrum, which turns into an observation of a conscious human being that can still observe the world through the visual sense. This is a whole lot more to handle than a simple 1, 2, 3. How would you order the colors? How would you put them into relation with each other? What is belongs to what? Which of the following 4 words would you assign a lower distance between each other? Green, blue, sky, leaf. Categorical data can, but doesn't have to, follow some sort of ordering. Often, however, categorical data may be distinct or even overlapping. Sometimes possible values of a category set can have relations between each other, sometimes they have nothing to do with each other whatsoever. All of these concepts need to be kept in mind when transferring categorical input into a numeric vector space.
Okay, so this is important. Right now we are turning our data into a numerical vector space. Okay. So this is what we are doing, and
A categorical variable is a variable that can take on one of a limited, and usually fixed number of possible values, assigning each individual or other unit of observation to a particular group or nominal category on the basis of some qualitative property.
okay, so there are domain agnostic solutions, ordinal encoding.
Let's start with the simplest form, assigning each possible category an integer and pass it along. This is an enormously naive way of handling the data, and it usually serves no good other than to make it work, meaning the program won't crash anymore. When looking at the country column, one may then expect something like this.
Okay, so you see each of the country is yes, numbered between -1 and 1, I think. Okay, yes. So this is how they have assigned numbers to the countries.
There are several downsides to this approach. Canada equals 1/2 asterisk China and Vietnam equals 40/39 asterisk United States. Any higher level information about these countries is lost in translation. The results show less performance when using my benchmark predictor network.
Okay.
One hot encoding. The one that I found most often to be the recommended approach is OHE, also called dummy encoding. It's explained on nearly every page that pops up when searching for categorical data neural networks. It's also part of SECourses and therefore very quick to apply to a dataset. The principle is simple and best shown with a bit of code.
Okay, what I see is it is either 0 or 1. However, the results have been improved, as you can see. So this is either 0 or 1. I don't know it is based on what. Okay, let's see the other methods.
Embedding categorical data. This paper and this post about it both describe how to turn tabular data into something a neural network can manage.
Hmm. Okay, so you can select domain specific So for example, school is like this and university is like this. String metadata. Okay. So I think I will give the data like three distinct way. Okay, we see that all the data is between 0 and 1, and because they are scaled to that way. I don't know if there is a bigger than 1. So what I'm going to do is I will replace data like this. So my category data are M, F, and I. So I am going to set I as a 0, 0.0, and I will replace M as a 0.5, So this is being the decimal separator, and I will replace F as a 1, 0. Okay. So this is my arbitrary conversation, because actually there is no order between these three. Maybe there can be order between infant and adults. Okay, let's see what kind of results we will obtain. Okay, our data is generated. So, oh, by the way, we have forgotten to increase our counter. Okay. Okay, so, okay, this is our input. You see each one have 9 values. First 8 of them are the attributes, and the last one is the class. Okay. So every value is read. Let's see. This is the 162 example. So it is 0.605. Let's check it. Okay, so it is correctly assigned. And we can check the 12th one. For example, 0.43. So I am verifying that my data is correctly read. Okay, it is correctly read. Okay, now I have the input data, and I also need the output data. So I am going to change the way my array works. How am I going to do that? I am going to take only first, or let's say select or pick. I'm trying to. I think there was a way to take only a certain number of them. Okay, I'm trying to find. Okay, there's skip. Okay, let's try skip last. I'm not sure will this work or not. Skip last one. Okay, let's try this way. So I will take only the first 8 values in the text file, The last one is because the class. Okay, yes, looks correct. Okay, and same way I am going to use this one to assign the output method like this. Okay, this will hold the classes of the input with the same order. This time I will use just the skip, and it will be first 8. By the way, I know or oh, by the way, I can use just last for this one. Okay, so this should work as well. And this is interesting. It says its character. Oh, by the way, since I am taking the last, I don't need the make it like this. What I'm going to do is, yeah, let me show you. Since this is not an array, it will be only single value. Okay. Yeah, what I need to do is this time new double 1 and okay, like this. Okay, now it should work. Let's check it out. Oh, by the way, I have used the same object. This should be output. Okay. All right, let's check our output data. Okay, and it looks correct. All right, now we have read the data as in the format of our framework requires. Now we have passed this part, and then there is the perceptron part. Okay, let's go step by step. Then this will require me to activation network. This is inside which reference accord. Okay, accord machine learning. Let's get that library as well from NuGet. Okay, here let's install it. Okay, now let's see if the necessary. Okay, still not installed. Let's look from here. It So this is from accord.neuro activation method. Okay, I need to install Neuro as well. Okay. here. All right, so okay, now it works. For this one, what we need? Okay, this one. Okay, it says no variables exist. So let's check what is variables. Inputs count and narrows count. Activation function, inputs count and narrows count. Okay, so all right, this is important. How we are going to use our data? I will split my data into the 10 fold. How am I going to do that? I can write a method extension to do it, or we can just write it here as well. So we know the number of examples we have, and let's split it. Yeah, this looks in a better way. Okay, I think I will leave you the K and N, and for uh, let's make it work with first assigning them with splitting them, and then making it work. Then we can use K and fold cross validation later. So I believe this data is already shuffled. Okay, and we can also shuffle it like here. I will make it shuffle first. File equal to list, and then okay, yes, this is the answer what I need. Equal to, so this will order the my list, I mean the all of the lines here, and then I will write it back. So this will be a shuffling. Okay, here first I have read all the lines into a list, and I have chain randomly sorted them. This is randomly sorting. Then I have write back all the lines into the same file. So whenever I run the application, this will shuffle the code. Okay. And since we have shuffled, I am going to get the 10% of the data as input training data, and the rest will be used as testing data. So okay, perceptron network. Okay, so where is the learning? It takes network, and network takes variables count. Okay, I still couldn't find where the training happens. So where is this input is used? Oh, here. So you see run epoch of the learning procedure input and output. Okay, so this is where the input and output is used for learning. Okay, it is easy. Okay, let's make the training on the entire dataset first. Then we can split it to, let's say, test. Okay, so the variables is the inputs count. So first we will train on the entire set, and we will see the training success rate. It is also an important factor to determine how good is our algorithm. And there is learning rate, and let's see the learning rate. Okay, so this is the default learning rate. I'm going to use it. Oh, this is double, by the way. Okay, and then there is this one. By the way, how many times it is running? Okay, while needs stop. I think we can copy and paste this exactly as it is. Because we will be doing training on the entire set. Okay, save statistics to file. So let's copy this as well. Private rule. True. Yes, I want to save statistics to file. And what else there is? By the way, it has to be static in our example. And there's array list. Okay. Okay, there is need to stop, which is this one. I'm going to make it private. Okay, let's see when it is used. Oh, by the way, they have set need to stop themselves, so we needed to change it ourselves. Okay, there is variables. Variables is the I am going to set a new count. New variable int ir. Let's say element count equal to, currently this is equal to number of examples, so I'm going to use it here and here and set text. Okay, let's see the set text method they have made. Okay, oh, we don't need this. Oh, this shows the current iteration, so I'm going to use console write line as current iteration equal to like this and 0, which will format my count, and there is chart. Show classifier in the case of two-dimensional data. Okay, we don't need chart right now. Actually, we can't use it at all because we are using console application. There is show perceptron weights. We don't also need this. But we can write the perceptron weights to a file. The weights file is, oh, there is already file create. Yeah, okay. So this will write statistics to the file at every case, which I don't want. So iteration is increased every time. I'm going to delete this as well. There is show error dynamics. Okay, I don't need this as well as. And there is catch IO exception. Okay, we don't need this. 2. Catch exception A. And so, okay, there is weights file. Okay. Okay, so this is opening the file. There is write and write line. Yeah, okay, this should work. I'm going to set this as auto flash true so we can see. And okay, we should of course show the error rate as like this to string. I will show it with n3. Okay. Okay, so let's run the application and see what we get on the screen. Oh, it requires So I need to set it here. Oh, we didn't see anything because an exception happened. Something. Yes. Wrong length of the input vector. I'm going to remove this try catch so we can see the error when it happens. So it says there was a wrong length of the input error. I think we need to provide -1 here. And we are currently doing with only one layer of one perceptron of neuron. Yeah. Okay, we are just doing with one perceptron right now. Let's see the error rate. Okay. Neuron weights. Okay, the neuron weights are like this. And what is the error? Index was outside the bounds. Okay, I need to set this -1 so it will work. I'm going to rename it so it will be more specific. This is in inputs count, inputs count, layers count. What is the error we are getting? Wrong length of the input error. Interesting. Hmm. Okay, let's try to understand from this example what is the length of the input. Okay, so there are 8 outputs, so 8 variables. Oh, it says there are 3 variables, so variables is something else. I see, variables is the number of features. Okay, so we were providing a different thing actually. Okay, now we got the idea. Our number of features is, I'm going to set it dynamically, which is 0 point length. Okay. Count. Okay, this should be dynamic to get it. Okay, and we are going to provide it here. And let's see. Yeah. Yes. Okay, let's try again. I hope it will work this time. Yeah. Oh, our array rate is just too much, as you can see, and it doesn't get any better because we have just set single neuron. Okay, so we need to set number of neurons in each layer. I'm going to set it as if integers, and let's make it random. It is getting what? Params integer. Okay, like this. Of equal to, let's make it three layers, and I'm going to set each of them as 100. I wonder how will it work. Invalid neuron. It should have one layer only. Oh, why is that? This is weird. Why? Maybe like this. What? I shouldn't this way. Threshold function. You see how hard it is to just make the first setup. Inputs, classes, then outputs. Okay, new activation function like this. New activation network. Okay, so instead of threshold function, maybe we need to use something else. Yeah, let's use this. Polar sigmoid function like this. Four inputs, 5 hidden arrows, and 3 possible outputs. So inputs count, params int, narrows count. Ah, I see. I see. Narrows count. So the final network has to have number of classes output. Okay, so how many different number of classes we have? We need to calculate that. Equal to, okay, select or distinct count. To list like this. Let's check this way. It should have one layer only. Why? Why it has to have one layer? 4 inputs, 5 hidden arrows, and 3 possible outputs. Okay, I am going to set number of features. Can I make it work like this? Layers, activation layers, inputs count. There is another example. with alpha value 1, neuron in first layer 1. Mm, 1 and 1. Let's try with 1 and 1. Okay, so input layer, layer 1, layer 2, layer 4. Training data, output data, okay. Take some information here. Input layer dimension, dimension of the hidden layer and output layer. Input length. This is interesting. Why this is not working? Oh, I need to change activation perhaps. Let's change this activation neuron and let's make this 1. I wonder what will it work or not. This is giving error. What if we try like this? So far we are having trouble to Maybe I can try this. Dimension of the hidden layer and output layer. There is deep belief network. Algorithm where counts. Okay, let's look from here. Activation network. Layers is an array of layers. Okay, function. Okay, so there is a simple example of this. Let's try it. New sigmoid function, 3 inputs. So inputs is here. It has 2 layers. Okay, I'm going to make the first layer like this and the output layer like this. And then this is activation network and there is network and there is perceptron, I think. Invalid neural network, it should have one layer. Okay, yes, I get this error, but why it is happening? So probably it is related to our activation network. Okay. It must be related to that one. inputs layers and so this is backpropagation learning. What if we use this? I wonder that. Let's see it. While true, I'm going to print this to the screen. Zero, two, index not outside the bonds. Why? Okay, two inputs, yes, two neurons, yes, and one neuron in the second layer. Okay, I'm going to change this into, what is this? Okay, it takes alpha. Okay, number of features here. First layer, I'm going to set the first layer as the number of examples. And I'm going to set the output as the like this. Okay, this should work. Let's see it. Okay, why we are still getting error? Oh, we have problem with the final class count. Yes, it is not correct to count. Okay, I will make it like this. Let's set. Okay, output classes. You see, we just discovered an error in our code. And add item. So this will add it only for unique dot 0. Oh, I need to make this double. Okay, so we had an error how to calculate the number of final different number of classes, and I have just fixed it. Okay, we are still getting error, which is very annoying. Okay, let's remove this into like this. and see if our previous network will work or not. Let's try this function. Manipulate. We need to find the perceptron. Accord neural learning, perceptron learning. Let's find this class from GitHub. You see the documentation of the library you are using is extremely important. When you don't have proper documentation, you'll spend time like me. So I'm going to find this class. Okay, here, and this is the source code of the algorithm, and let's see the error. Activation. Okay, oh, I see. So it appears that perceptron learning is taking only single layer. Okay. So how many layers we have currently? So we need to use another learning. This is perceptron learning, but not multi-layer perceptron learning. We are working. We need multi-layer perceptron learning, and it uses this method, which is network layers length. Let's see how many layers we have. We have to change our algorithm to solve this problem. Okay. Okay, when I move, oh, it says we have two layers. Yes, it is true. We have currently two layers. If I remove this, it will work. However, this time we will have very poor performance. Oh, we are still getting error. This time we are getting error of index. It uses run method, and run method is coming from let's see the run class where it is running. I think we can see it from here. Oh, here. And the definition is coming from supervised learning interface. Okay, and If we change the final class count, okay, so our perceptron, yes, this is single perceptron algorithm. That is why we have wasted time. It can only classify 2 classes, not 26. Okay, record multi-class perceptron. Okay, to I wonder if there is multi-class here. One layer, perceptron delta rule. Okay, it says number of classes. There is sample 1. Number of classes 3. And this is delta rule learning. Where is it? Here. Levels count. Oh, this is delta rule learning teacher. Okay, let's try this. I wonder if this one will work. So this requires one perceptron requires single layer, and I'm going to try delta rule learning. Okay, it has generated number of neurons equal to the number of output. Yes, here. So why I am still getting index but outside the bounds of the array? Error. Interesting. So what is the error reason? It has 4 classes, but it is working. Layers. Inputs, column, levels, output, layers. says output is null. Why? Output has 4. Oh, I see now. Okay. So it appears that our output class has to be same as number of classes. Okay. So this narrows count is coming from I think, let me show what I mean. So this is the start button, click. And click, okay, this is used. And let's go here, okay. So there is learning trait, sigmoid, and whatever there is. And there is update settings. Probably this is. I see, okay. So we have to set the output differently. Yeah, I see. Okay. So what we are going to do is we are changing the output assignment. How we are changing it? Output class and okay. If, by the way, yeah, we have to do a for each first for the output class. Equal to this one. And okay, if contains equal to false. Okay. By the way, I don't need this. It will be like this. Add. I am sure there are already methods to handle all of this, but we are doing the raw method right now. So the output will be like this, new double equal to count, okay, and then all will be by default 0, as you know, and we are going to set the certain output here will be a 0 LST index of equal to 1. Okay. Is this the correct way? But I am not sure. Okay, there is deep leaf networks. Maybe it is better fitting for ourselves. I'm going to download it. Let's try this first and we can check it later. Okay. Yeah, this time it is working. Error rate is pretty bad and incorrect. Okay, so this was the output. Okay, it fixed our problem, but it didn't improve our algorithm, so I am going to check the deep leaf networks and let's download the application. By the for delta, which function they did use? Or they did use the sigmoid alpha value, which is by default 2. Let's try it. I want to see how will this work. Okay, deep learning. You know, we may not be successful on this dataset with neural networks as well. It is not guaranteed because this dataset may not be suitable for neural networks or perceptron algorithm. Yeah, or by the way, this error rate is the number of erroneous classification, I think. Yeah, it gets better or something. Let's check the error. What does it mean? How the error is calculated, I am going to check it. Okay, run layers, learning rate, error file. Okay, there is deep learning and deep learning uses okay, attention network, selecting index. I think this also uses run epoch. Yeah, here. Okay, so it uses three double inputs, batch size, learn model. Okay, so this is the learn layer, unsupervised. Where is the, okay, supervised is here. So it uses backpropagation network, and it takes the inputs and the outputs. So it is backpropagation network, and it takes momentum and learning rate. Yeah, this is actually what we needed. Okay. Anyway, let's run our application to see how it behaves. Okay, you see our error rate is getting reduced by each epoch. I want to see how much it will become. Yeah, it is still getting reduced, but it is really slow. You see the number of iterations. It may take a very long time to get a better error. Okay, there is a wait file. Okay, you see the weights are updated. I think these are the weights of the. Okay, there are 8 weights, and how many neurons there are? Creation function, inputs count 8, outputs. Okay, so there is single neuron. It has, oh, it has 28 neurons. I think it is the one neuron in the second layer and 2 inputs. Maybe we can add another neuron here. And I will move this to make it faster. Let's see. Oh, since this is perceptron, we can't increase the number of layers. So for each output, there can be only maximum one layer, which is divided on the number of outputs. But the error rate is pretty big. Maybe we can change our activation function. Instead of sigmoid, what functions we can use? Activation. Function. Equal to. Let's see the activation functions. Oh, there are maybe the accord net is not the best one for perceptron algorithm or deep neural networks. However, I think you have now the idea of how to do machine learning classification. So there is Bernoulli function. Let's try with the Bernoulli function. Different activation functions can have different performance. Okay, you see it is getting reduced. Okay, there is single input layer and 28. Okay, so you see the activation function is as we said. Each neuron takes 8 inputs. This is the output of the neuron, random generator, threshold, and this is the base of the input. Okay, inputs count, output, threshold, and weights. Okay, so our network is currently composed by 8 inputs and 28 outputs with single layer. And of course, with single layer, we are not able to properly learn it. So we need something multi-layer. And I will try this. Let's see if we can make it work for the multi-layer. Okay, this is the algorithm and layer index. What is this? Okay, let's remove it. And it requires a network. Let's use a threshold function perhaps. Okay, activation network, and okay, layer data. Okay, here I am going to use this tree network, and okay, so this is supposed to be deep belief network, which is coming from here. Hmm. Okay, outputs. Hmm. Let's check this one. Okay, so inputs count will be number of features, and this will be neurons count, and this will be class count. Let's put that. Okay, momentum. Then it takes inputs and outputs. So this will be console write line. Okay, this will run for 500 iteration. I hope it works. Oh, this is taking a lot of time. Each epoch is taking a lot of time because we have put such a big network in action, but I am still not sure whether we are providing output correctly or not. That is my only concern at the moment. Okay, so our network has so many nodes. Okay, yeah, error rate didn't change. Why it didn't change? Let's try to understand. Okay, now it is running epoch. Okay, so decrease factor, increase factor, update lower bound, update upper bound, delta max, network. Clear some of scared errors. Threshold derivatives. Yeah, weighted updates. Weighted previous derivatives. Weighted derivatives. I think we can change parallel resilient back propagation learning. It is just too slow. Why? What if I reduce the number of neurons? Let's make it 100 neurons. You see, it is also another hard problem of how many neurons you should have. Okay, I think we may be having error in our output model. Okay, so let's see if they put some out example. Okay, so this is how they put the output. Input output is 0, 1, 2. 0, 0, 0, 0. Ah, I see. Yeah, our output looks incorrect. So each output has single class. Okay. So I'm going to change the output class to previous one. Output 2 and output 2 will have as the previous one. Okay, double, convert to double. Okay, here last and okay, so let's try with the output 2 and let's see the error rate with this way. Okay, yeah, it requires output to be as the number of final class count. If I make it 0, but it can't now this time. Yeah, you see error is much bigger. Okay, so this is not the correct way. So maybe we can increase the initial step to see. Okay, why we are not able to get any better performance? Let's run this application and see how it works. Okay, it says there are errors. Perceptron. Okay, backpropagation learning. I think this is a good one. Yeah, I will try this. I'm hoping that this will work. Let's remove this as well. And okay, let's try this. Function network 3, in sigmoid function 2, and the code is becoming much messier each time I copy paste. I know that. And let's try the backpropagation. So now we need to change these, of course. Are number of features, 2 neurons in the first layer, second neuron. Okay, number of is in the final class, and let's make it 100 to see. Okay, backpropagation network is also very slow. Let's make it 1. I wonder how will it work. Oh, with just 1 neuron, you see it is much faster and better. Okay, maybe with just neuron we can get a very good result. Interesting. So the number of neurons can affect your performance dramatically. Okay. And can we get a guess? There is momentum, learning rate. So the learning rate is, let's change the learning rate to equal to this one. What was the default learning rate? Oh, 0.1. Let's make it 0.5 and test it. Okay, that is what else? So you see, we can save and load. I think. Okay. Creates a gram matrix of given vectors. There is also that. And let's make it 10. I want to see it. And let's make it 0.5. So this is the sigmoid function. Yeah, it is getting much better. The error, as you can see, with a simpler data, I think we can get even better results. How can we do that? Yeah, let's try our algorithm with iris dataset. Okay, it is simpler one. So I'm going to use the iris data here. Yeah, only the final class is different with iris data. I'm going to get set iris set also as 1, iris versicolor as 2, iris Virginia as 3. Okay. And here. Okay, so error is getting lower and lower. To use the iris, also okay. Then I need to set the number of skip step here. So this time the class will be again last. Okay, so this should work, I think, perfectly fine. Everything else was dynamic. You see, the dynamic programming makes your job much easier. Okay. Oh, by the way, output 2 failed. Why is that? Oh, because of this. Okay, this should work. Okay, so you see the error is getting lower, lower, lower. Come on. Yes, so we have reached almost perfect error rate. It is okay. Yeah, our error rate is now only 2. However, this is not the percentage error. Let me check how we can calculate. Mm. Mm. Okay. Expected, predicted. Accords. Let's say Propagation learning accuracy. Okay, so this is the way of testing accuracy. To test the accuracy, so you see when we changed our dataset to something much simpler and easier, our error rate has dramatically reduced. So I'm going to set it as 1000 epoch and input length. So the network computes. What is the network variable here? It says it is a network here, network 3, compute input I and output I, number of correct, and assert area cool. Okay, so output result, output I first. Yeah, this looks correct. Oh, by the way, okay, let's check it. Output values. Okay, I will take a pause for a moment. Okay, so let's try compute and try to calculate our accuracy. Okay, so you see these are the output values. You see they are not like, I think, categorical. They are weighted, they are real valued, and the biggest value is taken as an output value, I think. Yeah, so 1000 was not enough. Okay, order by descending. I'm going to use array sort. So this will sort ascending, then I will use array reverse. So this will be, make it descending sort. And let's make it 5000. Okay. So with 5000 iteration, we are getting a really good amount of error rate. Yeah, even 2000 is good. No need to wait so much. Okay. Yeah. Okay. So these are the output values. You see, it has only single value that is bigger than 0.5. That means it is that class. Okay. Oh, by the way, when we sort it, we lose which class it is. Therefore, I cannot sort. I see. The output results. Yeah. Okay. Oh, yeah. I shouldn't do this. This is the correct way. We don't need sorting. So I am going to write this as a, let's say, method. Okay. Inside here, static double, calculate accuracy, which will take a network. Okay, activation network 3 will take jagged array of double input, and it will take jagged array of double output, and it will calculate correct number, and accuracy will be equal to return number of correct, okay, over input count. I'm going to set this as a double. Okay. Or let's just say convert to double. Double plus 100 to string. Oh, by the way, so gets the all number of elements. Okay, let's comment this to see what it is really doing. Okay, let's call it here. So what I am going to call is network 3 input output. And okay, let's put, oh, we are too late. Okay, let's go step by step. So input length is 150. Why is that? Yeah, 150 because we have 150. Yeah. Okay, we have 150 examples or data in our iris data like this. Okay, let's remove this as well. And from here we have, okay, and output result is 1 if I first 0 first is 0 and this is 1. No, I need to calculate 1. Okay, this is 1. This is the second input. 1 first. Okay. So this is why we are providing incorrect output. This is a single layer class example. Therefore, output is only single dimension. So this is not the correct way of calculating. Yeah, I think I have an idea. This is input, the output. Yeah. Yeah, I think I have an idea. Yes, okay, we have another error here. To calculate, yeah, to calculate the correct class, what we need is to calculate the biggest index equal to -1. Yeah, equal to mean value. And no, this is not the way to calculate. If kk bigger than the biggest value, and this will be equal to count if length, okay, if output I and the key equal to 1, then it is correct. Yeah, I think this should work. So the biggest index. Okay, so with this way we can calculate the accuracy of the class like this. Biggest index is 0. It says y. Yeah, it is correct. So you see now it has 3 values and the output I is 0. So yeah, this is correct. Okay, so this should work. Our algorithm should work. Correct. Input count plus true. By the way, it will be input length. So string and 2 plus %. Yes, this will be a string. And I'm going to write stop accuracy equal to let's see the accuracy of our algorithm. So this way we can predict new ones as well. Okay, our accuracy seems like, yeah, it is not working as expected. Always same. Why is that? This is interesting. Our output looks incorrect. Oh no, it is not incorrect because we are shuffling each time. However, our accuracy is looking erroneous. Why is that? So 54 correct. It is almost always same. Maybe we need more iterations. Let's see it. Let's make it 20,000. Okay, let's change some values, maybe with one neuron. Yeah, it is still same. Okay, let's put 100 neurons, or let's say 200 neurons. Input counts false. Okay, this is wrong. Output all what 3 1. Okay. Inputs first layer, second layer. Four, four. The error never changes. It is really, I mean, the accuracy really weird. Okay, the output, the biggest output changes though. I see. Yes, now I know the reason. Because we have to reset this for every. Okay, now we will see the real accuracy. You see, when programming, there can be very easy mistakes, but they may cause very big problems to you. Like it was happening to us. Oh, it is. Oh, you see, sometimes the accuracy gets very bad, very good, and then it becomes very bad again. I see there are some 99% accuracy. Okay, so 404 didn't help us. Okay, so let's change the number of neurons here to 10, and okay, let's change the learning rate to 1. Accuracy is still the same. I think I'm going to change something more. Let's make this 0.1 and let's write the error as and 2. And 2 means shows only 2 decimals. Okay, here you see. Okay. So error rate never changes, accuracy never changes. When we have 100, let's make it 1. One layer. Okay. Accuracy is very widely changing. That is weird. You see sometimes 93%, sometimes 96%. Okay, sometimes 91%. If I make this how many neurons you want to put can widely affect your performance. If we make it just same as single perceptron, I did just put as 0 to the second layer to testing purposes. So there are basically 3 input and as number of class output. If I put there 1000, what happens then? So it is up to you, the design and your accuracy. So you see when there are 1000 weights, it is much slower and also it is not that good either. There is momentum and learning rate. When I click the network, I see the layers. Okay, the first layer has 1000 neurons and each neuron has 4 inputs, 4 weights, as you can see. And there is second layer. It also has 1000 neurons. Why? If I remove this, what happens? I want to see. Okay, there is neuron errors, threshold updates, and weighted updates. Let's check the network. Okay, it has one layer which has 4 inputs and 3 neurons. Yeah. One layer, 4 inputs, 3 neurons. So this is basically single perceptron. Let's see the accuracy of this. Okay, so accuracy is not increasing. Oh, as the weights get updated, it is getting better. I want to see. Let's see. There is also momentum. And what is the default value of momentum? Let's make the momentum like this and see how it affects. Okay, we have obtained 94%, 95%, 96%. Okay, increasing. You see, for each data set you are working on, you have to find the proper setup. Okay, this is really good. We are almost 100%, and it is 96.67. Okay, we can save this to use again. Okay, yeah, it is not changing anymore. We are over 100,000 epoch. So this is not converging. However, it is really good result, and it doesn't change anymore. So if I put a breakpoint here, I can see the weights of the neurons. So these are the weights of the neurons, weighted updates of the backpropagation teacher, and when I check the network, I can see it has one layer which has 3 neurons, and each neuron has 4 input weights. Okay, so with just 3 neurons, each one having 4 weights, I have successfully classified this. I can also have another layer of neurons, and let's see if will this increase our success rate. Yeah, you see, after certain number of epochs, we are starting to get better rates. We are still not at the maximum. However, this is only the accuracy of the training set. This is not the actual performance. For actual performance, we need to have a separate test set, and we need to make tests on that test set and do training on the training set. So we need to separate them. Okay, let's pause for a moment. Okay, these are the accuracies we have obtained. Okay, so there is 96% accuracy. Let's check the network. The network has 2 layers, and one layer has 4 3 neurons, and each neuron has 4 weights, as you can see. And the second layer, let's check the second layer. Second layer also has 3 neurons. So I can put another layer here, another. I can set as many as layer I want. Let's see how many. By the way, each layer you add multiplies the number of neurons you have, or number of the connections you have between neurons. So basically, this is using currently sigmoid function to determine whether that neuron fires or not. Actually, the sum of the outputs of the previous neurons we have, as we have seen at the previous language, and if you have watched the video links that I have provided in the previous lecture, you will know that. Okay, this lecture has been too long at the moment. Okay, you see this is not converging. I think I will just put, maybe we can put, what if we change this? What happens? Yeah, it gives error. Okay, as I expected. If we change the output as well, it will also give error. Yeah. So the first input and the last input has to be same as the number of classes and features you have. However, you can change the number of inner layers. It is totally up to you. When I set 90 inner layers, by the way, this has single inner layer, hidden layer, or we can say hidden layer. At the moment, it has single hidden layer which has 90 neurons. Try to imagine that in your mind. Maybe we can see. Okay, so oh, here. So we have how many inputs and how many neurons. Okay. We have one hidden layer. How many features we have as input? We have 4 input features, and we have currently 90 neurons here. Okay. Oh, it doesn't allow to put more neurons. And we have output of 3. Okay. I wonder if there is any other. No, there isn't. So we have currently 90 here, 4 here, and 3 here. Okay. So if I add another layer, I can show you. Okay. So we have 90 neuron on here. We have 4 input here, and we have 3 output here. This is not the neurons. Okay, you see it didn't work well, or it will work after a lot of iteration. Bit, let's say 12. Let's try the 12th number. It is the product of input and output. Yeah, error rate changes. Okay, still changing. Yeah. Okay, you see, now we are able to obtain 97 accuracy. You see, our error also decreased. Now we are having a really good accuracy and really low error rate. Okay, it is almost as zero error. It is only 1.93, and our accuracy is 98.67. Oh, it's changing again. Maybe we can get 100%. I am seeing 99%. Yeah, it is getting 99%. So you can stop the epoch when you get over 99%, or let's say after 100,000 iteration. It may never converge. It totally depends on your setup. So I may reach 100% accuracy as well when I use 100 100 neurons in the hidden layer. Let's make this run and let's see if there is any other visualization. Okay, I think I will continue to improve this software at the next lesson, so you will understand how to save model and load that model to do test. Once you have the basic setup, you can try so many different let's say so many different activation functions or machine learning algorithms. It uses all the same principle in AccordNet framework. Okay, so this is the end of lecture. I am uploading this to our GitHub repository. Hopefully see you next week. Okay, let's upload it first. Okay, hopefully see you next week. You can always ask me questions from my email or from our Discord channel. And we are looking for volunteers to fix our previous subtitles. Currently, let's see our status. Okay, so we are awaiting volunteer students for 4, 5, and 6.